we have an integral arcsine square d theta, arcsine x squared dx. Now let me use the two methods here. Okay, the first method is that to start with the substitution, right? We let theta is equal to arcsine x. Arcsine x is an angle, so the angle equals theta. Then x is equal to sine theta. And dx is equal to d sine x, sine theta. Okay, so this integral becomes integral theta square, right? D sine theta. That's right. Now the reason I'm not expanded, d sine theta is equal to cosine theta d theta, but I'm writing d sine theta. The reason, because I'm going to use by parts. So this is a u, this is a dv. So theta square is a u, v is a sine theta. It's easier. No, I don't have to break it into cosine theta d theta. So this one is equal to uv. U times v, right? U is this, v is this, minus the v du. Integral v is this. Du is 2 theta d theta, right? Now it's easy to follow, right? And then theta is equal to, theta is equal to arcsine x. Sine theta is equal to x. Therefore, this one is equal to x times arcsine x squared, right? That is this. Minus 2. Now here, I'm writing integral theta and the d cosine theta. Well, sine theta d theta is a negative d cosine theta, right? So I change negative to positive here to equal that negative for cosine, right? See, the reason I'm writing this way, because I'm prepared by parts. Okay, this is u, this is dv. So this is v, this is u. It's easier. Okay, this is x arcsine x squared plus 2. Now this is uv. U is this. V is this. So the u v minus v du. V is this, right? V is a cosine theta. Du is d theta, right? So this one is equal to x arcsine x squared plus 2. This is theta is arcsine x. Cosine theta. Cosine theta. Now, let me use the spacer here. X equals sine theta. So this is a triangle. This is theta. This is x. This is 1, right? That becomes sine theta is x. So this will be 1 minus x squared. So cosine theta is square root 1 minus x squared over 1. Right? So cosine theta is this. 1 minus x is minus, this is a cosine, right? Sine theta. Plus c. Okay. So this one is x arcsine x square plus twice. Now I'm writing this one first because it will avoid the ambiguity. You know, x times this one. So this was the square root 1 minus x squared sine arcsine x minus 2 times this was sine theta is x minus 2x plus c. See, that is my result of the integral. Okay, this is the first method. You see here, I'm not breaking the bracket like this. I'm using this way to use that by parts because that one is easier. Okay, let me do the second method. Okay, the second method, integral arcsine x square dx. Now, if I'm not using substitution method in the beginning, I'm using by parts. So this is my u, this is my v, u dv. U is arcsine square, v is x. So this one is equal to uv, u times v, right? This is v, this is u. Minus v du. V is x, u is arcsine x square, right? So this is the method of by parts. Now this one is equal to x arcsine x square minus x, this is derivative is 2 arcsine x times the derivative arcsine, which is 1 over square root 1 minus x squared dx. Okay. All right. Good. Okay, here this is equal to x arcsine x square minus. Now here I try to organize the integrand to satisfy by parts the condition. So let me have a d 1 minus x squared. Okay. D minus x squared is equal to what? This one is equal to 1 over 2 square root 1 minus x squared multiplied by negative 2x dx, right? That derivative is equal to this. Now I do have a 2x. No, okay, 2 is cancelled, sorry. I do have a 1 over 1 over square root. This one I have it. I do have x, right? So I leave 2 out. Integral. This is arcsine x. 2 is here. X over this becomes this, right? So, but I have a negative here, so change it to positive. Yeah. That's right. Everything is followed, right? This one is equal to this. So that is x over this, right? 2 is outside, negative change to positive. Now, here, see, by parts again. This is my u, this is my v. So this one is equal to x arcsine x squared plus 2 u dv is equal to uv. This time this one, I write 1 minus x squared arcsine x squared. This way is better than arcsine x times square root 1 minus x squared, because it's ambiguous, you know. It could be misunderstood, arcsine x times this. Now, okay, minus integral v du. This is v. This is du. Du is equal to this. 1 minus x, right? dx. This is v. This is u. v du. v times du. du is this. So this one is equal to arc sine x square plus twice 1 minus x square arc sine x. This cancel out, becomes the right, this is negative x, right? Times 2. So that is the result. See, second method is much better. Without substitution, well, by parts, straightforward, you know, no interruption. I think this is a very good method. Okay, thank you for your watching.